Okay, today's lesson, we are doing two lessons. So the first lesson is on 1.4 solving equations. So we are starting with the multi-step equations. First, you will have some simpler equations to solve in your homework. So for number one, I have variables on both sides of the equation. So I want to make sure I put the variables on one side. It does not matter what side I move them to. Oftentimes, I like to have my variables be positive. So if I have negative 2x and I add 2x to cancel it out, then I must add 2x to the other side of my equal sign. So I'm balancing that equation. Now I have 7x. Still the minus 9 on the left would equal 8. And then I will go ahead and continue to now get x all by itself. So I need to undo that minus 9 and add 9 to both sides. So 7x would equal 17. And then I will divide by 7. Now you'll probably notice 17 divided by 7 is not a nice number. When you're entering things in your Math Excel program for your homework, you can enter that. Make sure you're checking what the directions are saying. Is it asking you to type it in as a decimal and round it to a certain point? It probably will not for an equation, so it's going to ask you to put it in a fraction form. So you would type in 17 sevenths. Okay. For problem number 2 here, we have some distributing to do before I can put some of those like terms together. I've got lots of variables of W everywhere. So the first thing I'm going to do is do some distributing. So that negative 3 is going to multiply both the 2W and the plus 1. That 12 is not distributing because it is not written right next to that parenthesis. So negative 3 times 2W would be negative 6W. Negative 3 times 1 is negative 3. On the other side, I've got that 7W in front, then I should distribute that negative 3. So I'll have negative 21 minus 3W. And then from here, I'll go ahead and combine like terms. Now, the steps that I take might not be the exact same steps you would be taking in this order. That's okay. I like to combine my like terms that are on the same side. So 12 minus 3 would give me 9. And then I have that minus 6W. I have 7W minus 3W that I can combine to get 4W minus 21. Now it's looking similar to how our first equation started with variables on both sides. So I want to get my variables all on the same side. I can choose to subtract 4W from both sides, or I can add 6W to both sides. So that is up to you. Like I said before, I like to keep things positive. Maybe I'll make less mistakes if I have less negatives. And so 4W plus 6W would make 10W minus 21. Then I will add 21. So I'll get 30 equals 10W. And then go ahead and divide both sides by 10. So W would equal 3. Okay, when you go to type things in, you don't have to write W equals 3 like you typically would when you're showing me your work. You would just type in the number 3 into our Math Excel program. Okay, for our next two examples, we are going to be solving what are called literal equations. So you have to solve for the indicated variable. So I'm not going to find a numerical answer like 3 in my last problem. Okay, so number 1, you see this a lot with formulas and having to rewrite them for a different variable. So we're going to solve for h. So we should see that h is right there. We're trying to get that h by itself. So just like I tried to get W by itself, what do I take care of first? I take care of any addition and subtraction first, and then I divide. I'm going to do the same thing with this problem. I take care of anything I am adding or subtracting. So I'm going to subtract 2r squared from s. So I can't actually subtract 2r squared from s, so I just write s minus 2r squared equals, I still have that 2 pi r h remaining on the right side. So then to get h completely by itself, it is being multiplied by that 2 pi r. So I'm going to divide by that whole thing of 2 pi r. from the right side and on the left side. Okay, from here you should be able to see 2 divided by 2 give me 1, pi divided by pi, that's the same number, so I get 1. R divided by R, I would get 1. So my final answer would be H equals S minus 2 pi R squared divided by 2 pi R. Okay, and in our Math Excel program, there you can use fractions, you can use exponents, you have all those tools for you to be able to type in your mathematical equations, expressions, whatever you need. Okay, all right, we'll look at the second example, number 2. We are going to solve this one for F. This is converting between Celsius and degrees Fahrenheit, if you care to know that this is the formula for that. Students sometimes have a hard time with this one because I'm solving for F and they think back to, oh, we have to distribute right away, because that's typically what we have to do when we're solving. If I distribute, what I'm trying to get by itself is F, and then I'm going to multiply it by 5/9. So I just attached more things to the variable I'm trying to get by itself. So I would suggest actually not distributing, and we want to get rid of this 5/9 first so that it's no longer in front of those parentheses that I could multiply through. Okay, so if I'm multiplying this side of the equation by 5/9, I can divide that by 5/9. Okay, if you think back to when you learn multiplying and dividing by fractions, if I divide by 5/9, I am multiplying by its reciprocal, 9/5. So I'm going to take, I'll rewrite it here. So 5/9 times F minus 32. I'm multiplying that by 9/5. And then I'm multiplying my C by 9/5 because I got to do that to both sides to keep this equation balanced. So then if you don't see what's happening here, you don't remember how you multiply and divide fractions. So 9 times 5 would be 45 over 45. That gives you 1. That's why when I take 5/9 divided by 5/9, I get 1. But it's the same thing as when I multiply by that reciprocal. I also get 1. We want to undo that. Okay, so from here, I'm just going to rewrite it so I don't have that crossed out, 45 over 45. And remember, we're solving for F. That needs to be alone. So I've got one more step. I need to add 32 to both sides. And then that would equal F. Okay, so what's nice about these problems is you really don't need a calculator for them. You are just undoing those operations and following the correct order for solving. And you wouldn't have to type in anything in the calculator if you're not great with your mental math skills. So that part is nice for these literal equations. Okay. All right, so we're already moving on to the next lesson. We're kind of do two little mini lessons. It's a lot of review. You've done solving equations, you've done solving inequalities in your other algebra courses. Just want to make sure we're confident in those because we'll see that a lot moving forward the rest of the semester. So this is a table I took from the book that you probably don't have in your possession, but here it is. We're going to fill in what the inequality would be that makes sense for the graph on the right, and what is x is greater than 4 would be written in that way. But that's my inequality symbol, the greater than symbol. When it's greater than, I use an open circle and I'm drawing my arrow to the right to show that all the numbers larger than 4 are to the right of 4, like 5, 6, 7, 8, and beyond. Okay, if I'm writing x is greater than or equal to 4, I put the little line underneath for equal to. Since it's equal to, now I'm closing that circle. And since it's still greater than that number, I'm pointing all the solutions off to the right because all of those are larger than 4. The next one, x is less than 4. So once again, open circle since it is not the equal to. And then less would be all the numbers to the left. And then the last one, x is less than or equal to 4. Now I'm closing that circle and drawing my line off to the left to represent all of those solutions that would satisfy that inequality. Okay, so that's our basics there of our inequality symbols. We'll go ahead and solve an inequality, and then when we find the solutions, we will graph them like we just looked at. Okay, very similar steps as to solving an equation. I'm going to go ahead and distribute. So I'll have negative 6x, negative 3 times a negative 5 and be a positive 15, plus 1 is greater than or equal to 4. I'm going to combine those since they're on the same side of that inequality sign. So the negative 6 plus 16 is greater than or equal to 4. I will then subtract 16 from both sides. And then I will divide both sides by negative 6. Okay. Something that you do need to remember, if you multiply or divide both sides of an inequality by a negative number, you must switch your sign. I'm sure that's a rule that you've been taught before in your previous algebra classes, but just a reminder there. So this means that I will get 1x, and since it was greater than or equal to, I need to flip that sign because I divided by a negative on each side to less than or equal to, and this would give me a positive 2. All right. When I go to type these things in Math Excel, make sure you always have your variable first, or it may mark it wrong for you. And then you'll be able to, the good news with our Math Excel program is you're not going to have to do many of these problems by hand when you're graphing, because you're just going to select the correct multiple choice for that part. So whenever I have them graphed by hand, put a number that's to the left of the number we have in our solution and a number to the right. Since it's equal to, I will close it. Where are all the numbers that are less than or equal to 2? They are all off to the left because 1 is less than or equal to 2. So that's what it would look like. Okay. All right. So moving on to, if you see any compound inequalities, then you are solving inequalities. You're solving more than one inequality, and then you graph those on the same number line. Now there's 2 clue words into what types of compound inequalities we will have. You will see ones that have the word and what that means, or what you're thinking of, that means all the values that make both of your inequalities true. Okay, the or would mean all the values that make at least one true. And when I say one, I mean one inequality that we're given. Okay, so we'll look at both an and example and an or example. So this is and because it says and. Okay, you just go ahead and solve each inequality separately. So I've got get x by itself, I'll subtract 1. So I have 6 is less than 2x. Divide both sides by 2. That'd be 3 is less than x. I will not type that way into Math Excel. It's going to want me to have that x variable first. So make sure when you rewrite it with that variable x in front, it still means the same thing as what I have right here. All right, this says 3 is less than x, or the other way to write it would be x is greater than 3. Either way, it's telling me x is the one that's supposed to be larger, 3 is the one that's supposed to be smaller, whether I'm writing the 3 in front or the x in front. So make sure your x would be in front for a Math Excel entry. This one, all I have to do is divide by 3. So then I have x is less than or equal to 6. So there is going to be a way that I'm going to write these 2 answers in one final answer, but I want to show you what this looks like on the graph. and thinking about what it means to be an and inequality. So since it must satisfy both things, that means, so I've got 3, 4, 5, 6. 6 would be a closed circle, and 3 would be an open circle. Let me use black here. Okay, and so since x must be less than 6, but also greater than 3, it's covering all of those values in between there. Okay, because that would satisfy both of those. Now, if I go smaller than 3, that would only satisfy this inequality. If I go larger than 3, it'll only satisfy that inequality. So it's going to represent all the answers in between. Okay, so then there's a special way how I write that compound inequality. I would say for all of my values x, I must be less than or equal to 6, but x must be greater than 3. So it's saying all of my values for x are between 3 and 6. And that's the way I'll have to enter in my and inequalities into the Math Excel program. Okay, because you got the two separate, but you're putting them as one. Okay. All right, last example, we'll look at an or inequality. So once again, I solve each of them separately. So divide both sides by 8. So x would be greater than -4. Or divide both sides by -6. Remember, I divided both sides by a negative once again, so I must switch that sign around. So that would give me -8. Okay, I put both of those on my number line. Now remember, if it's or, it means it could satisfy either inequality. So I include every possible answer that could be on this graph. So I've got -8, -5, -4. All right, so x is less than or equal to -8, but also it could be greater than -4. Okay, oftentimes your or problems go one way or the other. Okay, and oftentimes your and problems are the overlap that's connecting in the middle. That's not every single time. There's some special cases where that doesn't always happen, and we'll talk about that later in the week. But for the most part, this is what you can expect. And this would be my answer. I do not have to write that as one single inequality like I did my last problem, because it's representing that it can be either that or that. Instead of the and problem is saying it can only be between those. Okay, and that would be the difference. All right, that wraps up our first lesson. Good luck with your homework.